Hello everyone, greetings from Clavimate classes. So today we are going to revise application of integrals in one shot. Okay, with the help of some important questions. We have already studied integrals. Right? What is integral? Integral is antiderivative. Antiderivative. Right? So we have already studied integral and now in today's lecture we are going to revise application of integrals in one shot. Okay. So this is a one shot revision. It will cover important questions of this chapter. So let's start with the incurious things about this chapter. Application of integrals focuses on practical application of integrations. Like in integration we have studied all the formulas, methods, identities to solve integrals. Also we have studied definite and indefinite integrals. Okay, so we have already studied these topics: methods, definite integrals and indefinite integrations. So now in this chapter we study applications of this chapter, application of integrals, like in daily life how do we use integrals. Okay, so it is used to find area under the curve, area under two curves. Okay, so if we have given any curve, so what we do, we find area under this curve. Okay, or area, if we have given two curves, so what we do, we find area under these two curves with the help of integrals, right? So let's discuss more application of these chapters. Like in field of engineering, engineers use integrals to determine the shape of building, constructions or length of power cable required to connect two substations. Okay, so in the field of engineering this chapter is also used. How? To determine the shape of building, constructions of length of power cable, okay, to connect two substations, right? So let us see the mark distribution of this chapter. So in boards this chapter covers 5 or 6 mark questions. Okay, and in JEE Mains this chapter covers around 3% of the total portion. How much? 3% of the total portion. And in JEE Advanced this chapter carries one question. Okay, so this is also an important chapter, right? Okay, so let us discuss the topics to be covered. Okay, so the topics to be covered in this chapter are introduction of this chapter, applications in finding area under simple curves, especially lines, circles, parabolas, ellipses and hyperbolas. Okay, so we are going to discuss area under simple curves, okay, simple curves, lines, okay, lines like this or this. Okay, so these are lines, circles, ellipses, parabolas, this like this or this or like this or like this, parabolas and hyperbolas. Okay, or hyperbolas in standard form only. Okay, so let's start with our first question. So this is find the area of region bounded by the ellipse. Ellipse, okay, so the ellipse given to us is x square by 4 plus y square by 9 is equal to 1. And what we have to do? We have to find the area of the region bounded by the ellipse. Okay, so let's start solving this question. Firstly, we have to draw its figure. Okay, so let us draw its figure. So let us suppose this we have given x square by 4 plus y square by 9 is equal to 1. Okay, so if this is our ellipse, okay, like this we have our ellipse, this is our x axis, this is our y axis. So this point will be, can I write it as x square by 2 square plus y square by 3 square, right? So the points are 2 and 3. Okay, so here the point will be 0 comma 3, this point will be 0 comma minus 3, right? This will be the point of minor axis will be minus 2 comma 0 and here the point will be 2 comma 0. So why these points are 0? Because on x-axis points of y-axis remains 0, and on y-axis point of x-axis remains 0. Okay, so this is our ellipse, and we have to find the area of the region bounded by this ellipse. Like we have to find this area of the shaded region. Okay, so if I name this as A, B, C and D, so we have to find area A, B, C, D. Okay, so this is the area of ellipse. Okay, so let's start. If I take look, if I take this portion, we change the color. Okay, let us consider this portion first. It is A, C and ACD. Okay, so let's cover ACD. Okay, so can I write it as area of ellipse is equal to twice into area of ACD, because this area of ADC is equal to area of ABC, right? So I can write it as twice the area of ACD. Okay, so the area of ellipse is twice the area of ACD. Okay, now let us find area of this portion, the portion covered with green region. Okay, so let us find the area of this region. Okay, we have to find area of ACD. Okay, so what is the area of ACD? We know how do we write? We write it as integral of y dx into, what is the range of this? This is from minus 2 to 2, from minus 2 to 2, right? So area of portion ACD is integration of y dx from minus 2 to 2. Okay, okay, so let us move further. Now we have to find the value of y. How will we find the value of y? From this equation we will find the value of y. Okay, so by using this equation, let us find the value of y. So the value of y is, since x square by 4 plus y square by 9 is equal to 1, so y square by 9 is equal to 1 minus x square by 4. So I can write it as y square is equal to 9 into 1 minus x square by 4. Now what is y? Y will be equal to the root of this. Okay, y is equal to the root of this, or I can write it as y square, or we need y now. Okay, so I can write it as y is equal to under root 9 by 4 into 4 minus x square, right? So 9 by 4, let's take this out. So y is equal to plus minus 3 by 2 under root 4 minus x square. Okay, so now we have find the value of y. Okay, so we have the value of y as plus minus 3 by 2 under root 4 minus x square. Okay, so this region is above the x-axis. Okay, so this is positive, so we will take positive sign. Okay, so the value of y will be plus 3 by 2 under root 4 minus x square. Okay, so let us find the area of ellipse. So what was our area of ellipse? So area of ellipse was twice into minus 2 to 2 y dx, right? And we have to find the value of this portion. Okay, so let us say I, this is I. Okay, so I is equal to minus 2 to 2 y dx. Okay, okay, so what is y? Let us put the value of y. Y is 3 by 2 under root 4 minus x square, right? Now 3 by 2 is constant, so let's take this out. So we get 3 by 2 minus 2 to 2, from minus 2 to 2 under root 4 minus x square dx, right? Okay, so let us solve further. Now see this. This integral is of which form? This is of the form under root a square minus x square, okay, right? And we know the integral of under root a square minus minus x square is x by 2 under root a square minus x square plus a square by 2 sine inverse x upon a, right? So now what we have, a is 2, and what is x? X is x only, okay. So let us put a 2 in place of a, and we get we had 3 by 2 minus 2 to 2 under root 4 under root 2 square minus x square dx, okay. So let us open this identity. So it will be 3 by 2 minus 2 to 2, sorry, 3 by 2. Let's open this integral. It is 3 by 2, and what was our formula? X by 2 under root a square, which is 2 square, minus x square plus a square by 2, it means 2 square by 2 sine inverse x upon a. So it is x by 2, right? And what is our limit? Limit is from minus 2 to 2. Okay, let us solve this. It is 3 by 2 to x by 2 under root 4 square, 4 minus x square plus, this is cancelled, plus 2 sine inverse x by 2, and limit is from minus 2 to 2. Okay, so let us solve it further. So what will I get? I have to put limits now. Limits, upper limit and lower limit. So let us put upper limit and lower limit. Okay. I'll have 3 by 2. Let us put upper limit first. Okay, so what is our upper limit? Plus 2. Okay, so let us put, it was under root 1 by 2 under root, x by 2. So it will be 2 by 2 under root 4 minus 2 square plus 2 sine inverse x by a. So what I will write in place of x? I have to write 2 by 2. So this is our upper limit. Now let us put the lower limit. So lower limit will be minus x. What I have to write in place of x? Minus 2. Okay, so minus 2 by 2 under root 4 minus x square. It means minus 2 square plus 2 sine inverse x upon a. So I have to write minus 2 upon a is 2, right? So I have put it, I have put upper limit and the lower limit. Now let's solve this. This will be 1, and what I get here is 4 minus 4 is 0, okay, and it is 2 sine inverse 2 by 2, which is 2 sine inverse 1, right? And here I got minus 1 here, and 4 minus 4 minus 4 is 0, okay. So this term is 0, this term is 0, and it is 2 sine inverse minus 1, okay. So I get 3 by 2, 0 plus 2 sine inverse 1 minus 0 minus 2 sine inverse minus 1, right? Okay, now let's solve this further. We know minus sine inverse theta minus sine inverse, sorry, sine inverse minus theta is minus sine inverse theta, okay. So let us use this also here, okay. Now what I will get 3 by 2, 3 by 2, 2 sine inverse 1 minus, it will be minus 2 sine inverse 1, okay. Okay, so minus minus is plus, so it is 3 by 2, 2 plus 2 4 sine inverse 1, right? And what is the value of sine inverse 1? It is pi by 2, okay. So I get 6 into pi by 2, okay. Let me raise this. What I get? 6 sine inverse 6 into pi by 2, 6 into pi by 2. Okay, so it is 3 pi. Okay, it is 3 pi. Now the area of the region ACD. Okay, so the area of region ACD is 3 pi. Now we had to find the area of ellipse. So what is the area of ellipse? Area of ellipse was 2 into area of ACD, right? So area of ACD is 3 pi, so the area of ellipse is 2 into 3 pi, which is equal to 6 pi, and 6 pi unit square is our answer, is our final answer. Okay, so 6 pi square unit is our final answer. So we had what we did, we find the area of ellipse. Okay, so I hope this question is clear now. Now let us move to the next question, which is find the area of region bounded by the curve y square is equal to 9x, y square is equal to 9x, x is equal to 2 and x is equal to 4, and x axis. Okay, and x axis in the first quadrant. We have to write everything that is given to us. Y square is equal to 9x, x is equal to 2, x is equal to 4, and x axis, and also we have given first quadrant. Okay, so let's try this question again. Okay, so let's draw the figure first, right? So I'm going to draw figure first. Okay, so we have given parabola is y square is equal to 9x. So it is of the form y square is equal to 4ax, right? So this will be like this. Sorry, it will be like this. Okay, as we have given only first quadrant, right? So it will be like this. Okay, so this is our parabola. Okay, now we have also given x is equal to 2, so let us mark x is equal to 2. So okay, if this is 2, so this will be x is equal to 2, and it will be x is equal to 4. It is x is equal to 2, x is equal to 4, and the next thing we have given to x axis. Okay, so this is our x axis, and first quadrant we have given first quadrant, so we have to just find area of this portion. Okay, so this is y is equal to y, this is y square is equal to 9x, this is x is equal to 2, this is x is equal to 4, and this is x axis, and it is the first quadrant, so we have to find area of the shaded region. Okay, this is 2, this is 4, this is 0, and this is y square is equal to 9x. We have to find the area of the only for the shaded region. Let us mark this as a, b, c, d. Okay, so let's start solving this. So what will be the area of shaded region? Can I write it as area of ABCD? Area of ABCD is equal to, limit is from 2 to 4, 2 to 4 into y dx. Okay, to y dx. Okay, so let us find the value of y. Since y square given to us is 9x, y square is 9x, so what will be y? Y will be under root 9x, which is equal to plus minus 3 root x. Okay, it is equal to plus minus 3 root x, and since we have to find only in first quadrant, so we will take the positive sign. Okay, so let's write it here. Area of ABCD is equal to 2 to 4. What is what is y? Y is 3 root x into dx. Okay, so now let's solve this. Since 3 is a constant, I'll take it out. It is 3 into limit from 2 to 4 root x dx. Now I can write it as 2 to 4, 3 is outside. I can write it x power 1 by 2 dx. Now since we know x power n, integral of x power n is x power n plus 1 upon n plus 1, right? So we have 1 by 2. So what it will be? X power 1 by 2 plus 1 upon 1 by 2 plus 1. Okay, so let's solve this. So it will be 3 is here, it will be x power 1 by 2 plus 1 upon 1 by 2 plus 1. Okay, and the limit is from 2 to 4. Okay, let me write it here. We get 3 into x power 1 by 2 plus 1, which is x power 3 by 2 upon 3 by 2, and limit is from 2 to 4. Let us put the upper limit and the lower limit. So what is our upper limit? Upper limit is 4. Okay, so it will be 4 power 3 by 2 upon 3 by 2 minus 2 power 3 by 2 upon 3 by 2, right? So can I take this 3 by 2 outside? Okay, so I'll get 3 upon 3 by 2, and 4 power 3 by 2 I can write it as 2 power 2. Okay, 2 power 2 into 3 by 2, and I can write 2 as root 2 power 2 into 3 by 2, right? 3 by 2. Okay, so it is a 3 is cancelled by 3. 2 into this will cancel out. 2 power 3 minus root 2 power 3, right? So it becomes 2 into 8 minus 2 root 2, right? So this is our final answer. Okay, let us multiply 2. So what I'll get? I'll get 16 minus 4 root 2. So this is our final area. So the area of ABCD is 16 minus 4 root 2 square units. Okay. So I hope this question is clear. Okay, so this question was of it comes in 5 marks or in 6 marks. Okay, so this is also an important question, and I think the concepts used in this question are clear now. Okay, so let us move to the next question, which is it is a JEE Mains question. Let us read this out. The area of the region enclosed by the circle x square plus y square by is equal to 2, which is not common to the region bounded by the parabola y square is equal to x and the straight line y is equal to x. So what is being asked in this question? It is saying that we have to find the area enclosed by a circle. Okay, so enclosed by a circle. So let us draw a circle first. Okay, so this is our circle. Sorry, this is our circle. Okay, by a circle is x square plus y square is equal to 2. Okay, let's compare this with the standard equation of circle. What is the standard equation of circle? It is x square plus y square is equal to r square. So can I write it as root 2 square? So what is our r? R is plus minus root 2. Okay, since radius can't be negative, so I'm taking it as root 2. Okay, so the radius is root 2, right? Okay, so we have find the radius. Okay, let us solve this further. Now what we have to do now? Now we have to plot the parabola, which is y square is equal to x, and the straight line y is equal to x in this figure. Okay, let me plot it. Okay, so this is this is y square is equal to 2x, y square is equal to x, and here it is y square is equal to 1. Okay, so this is y square, y is equal to x, this is y square is equal to x, and this is our circle, which is x square plus y square is equal to 2, right? Okay, and what we have to find? We have to find the area of the region which is not common to the region bounded by the parabola. Okay, so this is the region bounded by parabola, and the y is equal to x and the circle. Okay, so what we have to find, we have to area which is not common to this region. Okay, so if I name it as a b, okay, and this is c, so if this is abc, what we have to find, we have to find area of circle minus area of ACB, right? We have to subtract this area of this shaded region, right? Okay, let us solve this further. Okay, so this is 0, this is the point. Okay, okay, we have to find the value of this point as sorry, we have to find the value of this point. Okay, so this is what is the value of this point? Since y square is equal to x, this is a common point of y square is equal to x, and y is equal to x. Okay, so what is the value of this, what is the value of this point? So let us find the value of this point. Okay, okay, since y is equal to, we have y is equal to x, y square is equal to x. Okay, let me put the value of let me put the value of this into x square plus y square is equal to 2. Okay, so x square plus x square is equal to 2, 2x square is equal to 2, so x square is equal to 1. So what is the value of x? Is equal to plus minus 1. Okay, and what will be the value of y? Y will also be 1. Okay, so this point is 1 comma 1, right? Okay, now let's start finding area. Okay, so area of the shaded region will be, we are finding the area of shaded region. Okay, area of ACB. Okay, it is equal to 0 to 1, 0 to 1 y dx, right? 0 to 1 y dx. Now what is the value of y here? Here, this is, this curve, this curve is parabola, it means y square is equal to x, and this line is y is equal to x. So what is y here? It is 0 to 1 root x minus x dx, right? Y, it is root x because y square is equal to x, so y is equal to root x. Okay, so I'm subtracting, I'm finding this area, so I have to subtract this from the parabola and this line. Okay, so I'm subtracting these two. So what is the value of y from parabola? It is root x. And what is the value of y from y is equal to x? Since y is equal to x, so y is x. Okay, so it is root x minus x dx. Okay, so let us solve this further. Okay, so I'm writing it here. It is 0 to 1 root x dx minus 0 to 1 x dx. Okay, so what is the value of root x? What is the integration of root x? It is x power 3 by 2 upon 3 by 2, right? And the limit is from 0 to 1. And what is the integration of x? It is x square by 2, and the limit is from 0 to 1. Okay, so let us put upper limit and lower limit, right? So I'm this is 2 by 3 outside, this is x power 3 by 2, 0 to 1 minus x square by 2, 0 to 1, right? I'm putting upper limit and lower limit, so here it will be 1 power 3 by 2 minus 0, and it will be 1 by 2 minus 1 square by 2 minus 0. Okay, so it is 2 by 3 into 1 minus 1 by 2. Okay, so this is 2 by 3 minus 1 by 2, which is equal to 6, and 4 minus 3 is 1, which is equal to 1 by 6. Okay, so the area of shaded region is 1 by 6. Area of shaded region is 1 by 6, and we had to find area which is not common to this region bounded by the curves. Okay, so what was the area which is not common? It was area of circle minus area of ACD. Okay, ACD, right? So what is area of ACD? It is 1 by 6. And what is the area of circle? Area of circle is pi r square. It is pi r square. And what is the value of r? It is root 2, right? So it is pi root 2 square, which is equal to 2 pi, right? So now final area is required, or I can write it as required area. Required area is pi r square minus 1 by 6. So sorry, it is 2 pi minus 1 by 6. Okay, which is equal to I am writing it here. Required area is equal to 2 pi minus 1 by 6, which is equal to 12 pi minus 1 by 6 square meter, right? So this is our required area, which was being asked in the question. Okay, so I hope the solution of this question is now clear. Okay, so, and also the concepts used in question are clear. Okay, so what we did, firstly we first of all we draw the figure of circle and the curves y square is equal to x, or sorry y is equal to x, and we had to find the area not bounded by these regions. Okay, so we had to find the area of this portion, this portion. Okay, this portion. Okay, and the area of this portion was area of circle minus area of shaded region. Okay, so I hope this question is now clear. Okay, so let's see the summary of this chapter. After completion of this chapter, a student shall be able to answer on application of integrals related to this. The student will be able to find the method of drawing graphs of line or circle or parabolas. Okay, like this is also a parabolas, and ellipse. Okay, we have studied ellipse. Okay, ellipse and